Good evening, this is Mr. Ish. You are joining me for this video. We're continuing with another interesting video over here to help you improve your math skills. Again, we'll be looking at two questions in this video right here. It will be on trapezoid, and let's just call it trapezoid derivation. Just because I'm using the word derivation, it does not mean we're looking at calculus or anything too complicated. So let the first question be this: show that the area of a trapezoid is equal to half times height times base 1 plus base 2, and that right there is a classic formula for a trapezoid. You know, the shape looks very much like this. It could be a regular or irregular trapezoid. If this right here is my base 1 from right here to here, and this here is my base 2, and we have a certain height over here, how can we determine this and derive this formula? Let's do it, and I tell you all, it's easy. Let the derivation procedure begin such as this. We can have an irregular trapezoid. We can call this y over here, side y. We can bring down these two perpendicular lines. We'll call this x. Since this right here is y and we've kind of created a rectangular square, this must be a y, and we'll call this a z. These perpendicular lines, you know very well, create right triangles or right angles. Well, they create right angles, but on either end they create a right triangle. We know this right here is a height. I see when I look at it here is two triangles and a square. If this is a triangle, the formula of this can be what? You know, triangles are half base times height. This triangle has a certain base and it's called an x. It has a certain height and it's called an h. And then you have a half. You know, half base times height. When I look at this triangle, I see a certain base, it's called a z. I see a certain height, it's still an h, because these are parallel lines. The bases of a trapezoid are always parallel, so you cannot have a slant or an incline to these. These are both h, equal dimension. I see a height, and then of course there's a 2, half base and height. When I look at this rectangle or the square, I see a length and a width, and we can just call that YH. Since this total shape is made up of three individual shapes, the total area is equal to the individual area of these three added. I have an XH over 2, I have a YH, and then I have a ZH over 2. I have a common denominator here popping up of 2. I have an XH, 2 goes into 1 time, 1 goes into 2 times, I get a 2YH. And then I have 2 going in here 1 time and a ZH. When I combine all of this and I isolate H, I see H and a 2 come out, and I have a X plus 2Y plus Z. You can see that in this numerator I can isolate an H, pull it out. I can pull out the 2 with it, H over 2, and have this left. Now let's do some substitutions over here. Let B1 equals Y. Let B2 equal all of this, which is made of X plus Y plus Z. If I'm seeing a B1 over here and I'm looking at a 2Y over here, you know this right here is 2Y. I can rewrite this as H over 2 times x plus y plus z plus y, because I ideally have 2 y's, so I can bring 2 y's right over here. One of those y's is consumed by a b1, the other x, y, z is consumed by a b2. So when you bring it all in with this substitution of b1 and a b2, you get h over 2 times b1, which is this y, and then plus b2, which is all of these three remaining items, and there it is. The formula has been derived, and it wasn't too hard. Alright, this second and last question for this video is not a derivation question by any means. It's just an algebra geometry question. We have a trapezoid drawn over here. You know, there's a little diagonal line coming in here because we have a triangle on either end and we have a square or rectangle in between, and we've drawn a diagonal. Our question over here is we have to find the length of that diagonal segment. From here up to here we have to find the length of the segment if the total area of this trapezoid was 30. How can we go about doing this? Well, we know we have something over here, a height, we have a base 1, we have a base 2. This side right over here is equal to this side over here because I have these two markings which show that these two little segments from here to here and from here to here are equal, so this must be 5 over 2. This right here corresponds to this side, which is 5. This total base over here, you can add them up. 5 over 2 is a 2.5 plus 2.5 is a 5 plus a 5. All of this right here is a 10. We know the area formula for a trapezoid is half times h times b1 plus b2. Plug in the numbers and solve for what you don't know. We don't know h, so we'll solve for h. Area is 30. We have a half, we have an h, and then we have b1 plus b2. 5 plus 10 is a 15. Solve for h. Take 2 on the other side, you get a 60, and you take 15 on the other side, it divides by 60, so 60 over 15 and we know height is equal to 4. Let's look at this little square part or rectangle part. It looks something like this. We have to find this diagonal. We know we have something side here called a 5, corresponding is a 5, and now we've determined the height to be a 4, and this right here is a 4. And now it's nothing more than just a right triangle, and you're just doing a square plus b square is equal to d square. You'll have 16 plus 25 is equal to d square, and d is equal to the root of all of this, which will be 41, and that right there will be your answer that you're looking for. It'll be root 41. The diagonal created right here has this value right here, and it should be right. And with that, we end this video. Thank you for watching. Stay tuned. Have a nice day.